This is the Math 3 video for Unit 2, Objective 2, and we will be going over solving and graphing absolute value equations. So we will both be solving and graphing. So in last unit you worked on graphing, so if you're a little rusty on that component, you might want to go back and watch a video or go back and look at some notes to brush up on graphing absolute value equations. So a couple of things just to kind of review, just to make sure we're a good spot here. So our parent function for linear absolute value, remember, is that V shape, right? So this is our parent function. And the vertex here, so this right here, let me zoom in just a little bit, is our start point, which is HK, right? So this guy right here, that is our start point. Okay, so then from there we look at M, which is our slope, right? Often referred to as our stretch as well. Because it is linear, we can call it slope, right? So slope you can repeat over and over again. Stretch you can only have on a curve and repeat once, right? Okay, so our slope, so we would go up, M, and over, right? And that would be our slope. And then we would reflect and have that kind of reflected point, which would be that same vertical distance and same horizontal distance, just the opposite way, okay? All right, so our H and our K, our start point that we would find, remember that we would look to see what's opposite, right? What's opposite for H, what opposite for K, because that's what zeroes it out, right? What makes it zero. And so that's where we get that start point. So whatever is being added or subtracted to X becomes the X value here for our start point, and whatever is being added or subtracted to Y becomes the Y value here for our start point, okay? And then just a reminder, absolute value. So absolute value is always positive because it is a distance, right? So when you talk about distance, you don't say, go, -2. You would say go left 2 or right 2. So absolute value is distance from 0. So if we have the absolute value of 2, that means we are 2 units. And also -2 units, they both would have a distance of 2, no matter where we are, right? So if we're here at +2, we are 2 units from 0. If we're over here at -2, we're also 2 units. Okay, so that is just a quick review of absolute value stuff. So for questions 1, 2, and 3, we're going to be doing both solving graphically and algebraically. So we're going to be doing both, okay, graphically and algebraically. So let's start with just solving graphically. Okay, so we're going to start with those steps first. So our first step is we want to make sure that we are very accurate when we graph our functions. So we want to accurately graph both of our functions, and then our answer is going to be where they are intersecting. Okay, so our first step would be to graph and then look for their intersection. So let's go ahead and take a look at question number 1. So here it tells us in the directions, accurately graph both f and g on the same set of axes. Okay, so we'll start with f of x. So I'm going to start with this equation right here, and I'm going to use pencil for that one. So I know f of x is the same as y, so I'll swap that out. And so if I look at that, that's already in descriptive or vertex form because there's no constant here that I need to move over to y. And so when I look at the start point here, so our start point, which is also our vertex, remember, I look to see what am I adding or subtracting to the x or the y value. So right here I have x plus 3, so my start point will be at -3 because we want to do the opposite there, right? So -3. Nothing's being added or subtracted to the y, so then that would be 0. So my vertex, or my start point, is at -3, 0, so that would be right here. And then my slope, or my stretch, whatever we want to, whatever word we use there, means the same thing. So our slope is the coefficient, or what I multiply my x term, which in this case is 1, so that would be 1 over 1. And then when I go to graph it, I need to make sure that I'm going up 1 over 1. And I can do that again, and I would want to because of that accurate part, right? So go up 1 over 1 again, right? And then I would just draw a straight line, so that would be my right side of my absolute value graph. And then I would mirror that or reflect over to the left. So I'm still going to go up 1, but I'm going to go left 1 instead. And then I'm going to do it one more time, up 1, left 1. And then I get that V shape, right? That V shape. So there is f of x, and I'm going to go ahead and label that. And then now from there, I want to graph g of x. So I'm going to use a different color for that. So I'm going to use a pen for this one. So I know for g of x equaling 2, again, g of x is the same as y. So that would just be y equals 2. So when I go to graph that, I know this is going to be a horizontal line because that is constant, right? Y equals 2 is a constant value. And so I go along the y-axis, so that's this one right here, so there's y. I go along the y-axis to where it's equal to 2, and then I draw a line that passes through that. So a line that passes through y equals 2, and then there is my g of x equation. And so then once I do that, so there's my two equations, f and g. I'm looking for where does f equal g, and I'm looking at x equals. So I'm only looking at the x values. So they intersect, right? This is where they intersect. That's step 2. So they intersect here, and that was at x equals -1. And they intersect one more time over here, and then that would be at -5. So they intersect at -1 and -5. So that is solving graphically. So the other thing that we need to do is we want to try to find where they intersect in a different way. Sorry. I was like trying to read something at the same time I was talking. Okay, so the other thing we have to do is solve algebraically. So we're looking for where do they intersect without having a graph, and that would be solving algebraically. So we should get the same solution, so we're hoping we'll still get that -1, -5. We're just going to do this a different way. So our very first step is always to isolate the absolute value. So that is always going to be our first step, is to isolate. So we need to make sure anything that is outside of that absolute value on the left needs to move over to the right. So that is always our first step. Okay. So for this one, that's already done for us, right? The absolute value is already by itself, so I don't need to do anything for step 1, right? It's already isolated. This is by itself, no number outside of that on the left. From there, we have to determine the number of solutions because that's going to tell us how many equations we need to create. So we might have to create 2 equations, no equations because it'll be a no solution, or 1 equation. So knowing whether or not we have 2 equations to solve, no equations to solve, or 1 equation to solve has to do with this front number here. So whatever this number is right here, if it is a positive value, so if it is a positive value, then that means I'm going to have 2 answers. Okay, so 2 answers. I'm going to abbreviate that. You cannot see that. There we go. If that number is positive, I'm going to have 2 answers because I'm going to have to create 2 equations. If this number here is negative, so if that is a negative number, then I am going to have no solutions at all. No solutions. No equations to solve, no solution at all. If that number is a 0, then I'm going to have just 1 answer, 1 equation to solve. Okay. All right, so if it's 2 solutions, I have to write 2 separate equations and solve them. So where my function is equal to that positive number, or where the negative of that function is also equal to that number, okay? So the negative or the positive, right, because absolute value, if that was positive, or if it were negative, doesn't matter what's inside there, I would still get the same value, okay? So for part B, on example 1 that we were working with, because this is a positive number, right? That's a positive number. I need to create 2 equations, right? So I'm going to have 2 equations, one where I look at that being positive, and then I also look at that being negative. Okay, not adding versus subtracting, but positive versus negative. So for that first equation, so x plus 3, so I would look at that as a positive. And I don't have to have a positive in front here, right, because that's implied, so I don't need to write that out. And then I need to have a negative version of that, so a negative version. And so that's how I create my 2 equations. So positive 2 means I need 2 equations for 2 answers. And then from there I just solve that just like I would anything else. So I would subtract 3 from both sides. And then I'm going to solve this one here. So I could distribute, right? Distributing is a fine way to do that, but I'm just going to divide the negative over to the other side. Okay, I could distribute, I just don't have to. So I'm going to divide the negative over, and that's just to save me a little bit of a hassle there, right? So I'm going to divide that negative to the other side, and then I'm going to subtract 3 from both sides. So my solutions are -5 and -1, right? Which is good, right? Because that's what we got when we solved it graphically, right? We got the same exact answer. Okay. Okay, so let's go ahead and take a look at question number 2. So again, the very first thing we always want to do is we want to make sure it's in descriptive form, and we're going to graph each of these. Okay, so I'm going to start with f of x. And remember, that's the same as y, so that would be y equals 3, and then the absolute value of x minus 1. So to graph this, I need to find my start and my slope. So for my start, it's already in vertex or descriptive form. So I have my x value here, so I have -1, so I'm going to do the opposite, so that would be +1. Nothing's being added or subtracted to y, so that would be 0. And then my slope, so my slope is what's multiplying, so that would be the 3. And I can always put that over 1, right? So this is like my rise over run. So my start point is at 1, 0, so I'm going to go over 1, up 0. And then my slope is 3 over 1, so I'm going to go up 3 and then over 1. And then I don't really have enough room to do that again, so we're just going to call that good and hope that'll be fine. And then I want to find the reflected side over here, so I'm going to go up 3 and then left 1. Kind of missed my dot there, so hopefully that'll be okay. All right, and then let's go ahead and find g of x and graph that. So g of x is the same as y, so I would have y equals -3. So again, I'm going to go on the y-axis, which is my vertical one, and then I'm going to go to where y is equal to -3. And then I'm going to draw a horizontal line that passes through where y is equal to -3. And then let me label both of those. So that's my g of x and my f of x. All right, and then for finding where f is equal to g, I look for intersections, right? So this is pointed up forever, so it's never going to come down to here. So these are never going to cross each other, so there is no place where they're going to intersect. And so I'm just going to write none. Okay. So that means for part B, we should get that none answer as well, right? These should be giving us, generating the same answer. So this is just 2 different ways to solve the same problem. So for part B, they're asking for where does f equal g, but we have to solve it algebraically. So I know f of x, so if I look over here, this is the equation for f of x. And then the equation for g of x, so equal to g of x. So again, step 1 is we always want to isolate, right? So we have to isolate first, meaning we need to get this absolute value equation by itself, right? That should be the first thing we do. So we need to get that 3 to the other side, so there's like an implied multiply there. So I'm going to divide both sides by 3. And this just equals 1 when I do that. And then -3 divided by 3 is -1. So then the first thing I need to do is decide how many equations, right, I need to create based upon like how many answers I should be looking for. So then I look at this number right here. And then this number is a negative number, right? A negative number. So because that is a negative number, then I will have no solutions. So I should have no equations, right? So there's no solutions, so I would have no equations. So then I don't need to keep solving that, right? That's a negative number, so then that is no solution. And I knew that from over here, right? I knew that from over here. Okay? All right, so if you feel pretty good about that, you should be pressing pause right now and then try number 3 on your own. Okay? So if you feel pretty good, you should press pause and then give number 3 a shot. Okay, so let's go ahead and get started here. So I'm going to go ahead and write this equation out. So this one I'll do in pencil here. So I have f of x, so that's the same as y. And so for that, I want to go ahead and put that in descriptive form. So I'm going to subtract 2 to both sides. So the constant here is over with the y, which is what it belongs to. Right? And then I want to find my start and then my slope or stretch. So my start, I want to do alphabetical order, x before y. So I start with my x value. So then that's going to be opposite here, so positive 1. And then opposite over here, so positive 2. And then my stretch or my slope, whatever word I want to use for that, is just going to be 1 again, right? Because there's an implied 1 here, so my slope would be 1. And then rise over run, so 1 over 1. So let's go to 1, 2, so over 1 up 2. So that's my start, my vertex. And then my slope is 1, so up 1 over 1, and then let's do it just one more time there. So we want to be accurate, right? So I can do that. I can do the slope as many times as I want, right? Because it's a linear line, so it's going to rise and run the same no matter where I'm at. And then I want to do the reflected side. Excuse me. So I'm still going to go up 1, but now I'm going to go left 1 instead, and then I'm going to do that a couple times also. And then let's go ahead and graph g of x. So g of x is the same as y also, so I'll write that out as y equals 2. So this is my y-axis, so I'm going to go along my y-axis to where it's equal to 2. And then I'm going to do a horizontal line that passes through the y-axis at 2. And then when I ask for where does f equal g graphically, that means where they intersect. So where do these two graphs intersect? They intersect at that vertex. But I only want to know the x value, right? I only want to know the x value. And so that would be right here at x is equal to 1. So then they intersect when x is equal to 1. Okay. All right, so then let's go ahead and take a look at part B. So we want to solve this algebraically. So for where f of x is equal to g of x. So when I do that, I'm going to just transfer those equations over. So let me scoot that back over. So here's f of x, so I'm going to replace that with f of x. So that will be the absolute value of x minus 1 plus 2. And I want to know when will that equal g of x, so when will that equal 2? All right, and then step 1 is isolate absolute value. So we're going to isolate the absolute value, meaning get that by itself. So in order to do that, I need to get the 2 to the other side. So I'm going to subtract 2 from both sides. And then as soon as I have this isolated, I have to determine how many equations, right? So to figure out the number of equations, so because it's equal to 0, I'm only going to have one solution, so one equation. So I don't need a positive and a negative, right? So that's a 0 here, so I only need one equation. So I just need to solve that. And so I just need to know where does x minus 1 equal 0. So all I do is drop the absolute value and then solve. And again, that's because that's 0. And then I'm going to add 1 to both sides. And so then I would have x is equal to 1. So the only place they intersect is at 1, and we knew that already from our graph over here. Okay. All right, so before I review that composition piece, like for this little section right here, so which is going to be for our 4 and 6 right here, so reviewing that, we're just going to go ahead and solve 5 and 7 though, because that's still kind of that same idea. So we're going to solve 5 and 7 first, just like we did on 1 through 3. So if you felt pretty good about solving, you might want to give both of those a try first. And then, so press pause, try it, and then forward to my answer and see if you got the same thing, okay? All right, so step 1 is we want to isolate, so we want to make sure we get the 2x minus 1 by itself. And so to isolate, I can't add the 8 and 4 together because 4 is actually multiplying the absolute value. It's not being added to 8, right? So I have to solve, so I cannot combine those. I need to just subtract 8 from both sides. So isolate meaning move the numbers over, don't incorporate them. So that would give me 0, and I would have that 4 there still. And then I still am looking to isolate, so now I need to move the 4 over to the other side. And I'm going to do that by dividing, because there's an implied multiplication there, and 4 divided by 4 is 1. And then once I do that, I determine how many equations I need. So I know this is a negative number. So if it is a negative number, so if you've forgotten, you can go back and look at that little cheat sheet. So if I have a negative number, then that means I have no equations, no solution, right? So that's on the front side of the notes. So this is no equation, no solution, right? And I could just use the symbol for that. And so then I'm done, because an absolute value cannot equal a negative number. Okay, all right, let's look at 7. So again, our first step here is to isolate the absolute value, so we want that by itself. So again, I cannot add 6 and 2 together, right? Can't do 6 minus 2, because negative 2 is multiplying this, because there's an implied multiplier here. And so that means I need to isolate, meaning get rid of things, don't incorporate them. So I would get rid of the 6 first by subtracting it over. And then still getting rid of that negative 2, and remember that's multiplying, so then I'm going to divide both sides by negative 2. And then once I get here, so now that I'm isolated, I look at this and I see that this is a positive number, right? So if that is a positive number, what do? Do I have and create 2 equations? No equations, or 1 equations, right? I always figure out 2 equations, 1 or none, right? 2, 1 or none. So because it's a positive number, I need 2 equations, 1 positive, 1 negative, and I solve for both. Okay, and again, that's because 8 is positive. I don't look up here and say, oh, negative, no solution. I look after I've isolated. So my first equation, this is exactly the same without the absolute value. My negative version without the absolute value. Okay, so positive of the inside, negative of the inside, and then I solve each of these. So the first thing I'm going to do is subtract 6 from both sides. And then now I want to get rid of the 2/3, so I'm going to multiply by the reciprocal, right? So I'm going to put this over 1, since I'm going to multiply by a fraction. So all I did was multiply by the reciprocal, so I would get 6 divided by 6, which is 1. And then here, straight across, so 6 divided by 2, which is 3. And now let's do the same over here. So again, I can distribute, but remember I'm trying to isolate, so I don't want to incorporate the negative, I want to move it over. So it's not wrong to distribute, it just, we don't want to incorporate it in, we want to divide it over to the other side. And then go ahead and solve. So I'm going to subtract 6 from both sides. And then multiply by the reciprocal again. So multiply by that 3 over 2, that over 1. So then that would be x is equal to negative 42 divided by 2, so negative 21. So x is either negative 21 or 3. Okay. All right, so there's those 2 practice problems. So let's go ahead and take a look at the review of the composition of functions. So this is going to be from last unit. You guys did composition of functions there. So there's 2 notations whenever we're composing. So whenever we talk about our composition, we're talking about merging functions together. So you'll be given 2 functions, like for example, number 4, you have f and g here. So they're just asking you to, come up with a way to merge these 2 functions so that you just have 1 instead of 2, right? So that's what we're working with here. So there's 2 different ways to write it. You can write it with kind of that open dot notation, which doesn't mean to multiply, right? So that's just that open dot notation does not mean to multiply. So that's one way. And so you also have where we use just the parentheses, like in a nested form. And they mean the same thing. So it's just like when we multiply, we can use the x for multiplication, or a dot, or parentheses, like different ways to write out multiply. you can do different ways to write out composition as well. So this is just two different ways that you need to be familiar with. And then specifically here, they have the G and then the F. It doesn't have to be that way. It could be flipped around, like first F, then G. So that's important though. So composition, merging our two functions together, it just means that whatever F is, like that function, it's going to substitute into G of X. So it will substitute in into G, right? Or if it was the other way, then it would go the other way. Okay, so our function F replaces our X value. So F replaces the values of X in G. Okay, so that is composition. So we merge our two equations into one, right? So we are going to merge two equations into one. And we do that through substitution, okay? All right, so let's take a look at number 4. So for here, they have G of X, right? So G of X is in the right-hand position, right? So we have these two functions, F and G, right? And we need to merge them, so we only have one. And how they want us to merge is because G is on the right, they want us to take G and substitute it into F. So we're going to take G, that whole thing there, and we're going to substitute it into F. So instead of this X, right, the simple little X here, we need to kick it out and replace it with 3X plus 6. And then still equal to 12. So what did we do? Put these two guys together, so gave that the absolute value, and then kept it equal to 12. Okay? And then we just solve it. So in order to solve it, we have to isolate the absolute value, which it already is, so that's pretty dreamy. And then we decide how many equations I need. So right here, so this is a positive number. So if that is a positive number, then I need to have two equations, a positive and a negative version. So my positive is the same without the absolute value. And then the negative version. So this would be a good time to go ahead and press pause, give it a try, and see what you came up with, okay? All right, so to solve this, I'm just going to subtract 6 from both sides, and then divide by 3. And then over here, I'm going to divide both sides by that negative. I don't want to distribute it in, not because I can't. I just want to move it over instead of incorporate it into the left. And then subtract 6 and divide by 3. So then my answer for this one is -6 and 2. Okay. All right, and then last problem, number 6, so still composition here. So I have just the other notation. So I'm going to take G because it's on the right and substitute it into F. So I'm going to take G and substitute it into F, right? So I'm trying to put these two equations together so that I only have one. And how am I going to do that? I'm going to make this 2x minus 1, replace that x. So that 1/3 is still here though, right? I need to use like all of the pieces here. So I have that 1/3. And then put the two equations together, so absolute value of 2x minus 1, and then minus 5, and then equals 0. So step 1, isolate the absolute value, so I need to get this guy by itself. So I'm going to go ahead and add 5 to the other side. Do my adding and subtracting first. And then I'm going to get rid of the 1/3 by multiplying by the reciprocal, so 3 over 1. So that would just be 3 divided by 3, which is 1. And then 5 times 3 is 15 divided by 1, so still 15. So again, how many equations? So this is a positive number. So that means I need to have two equations, right? So I'll have the positive version and the negative version. and then just solve that. Okay, so maybe press pause forward and see how you did at the end there. Okay, so we're going to hit just your basic solving. So we're going to add 1 to both sides and then divide by 2. And then same over here. So I'm going to divide both sides by -1. And then add 1. And finally divide by 2. So x is either -7 or 8. And that's it.